Okay, welcome. We are going to look at the solution of this problem here. This problem asks you to find the Thevenin voltage and current and resistance of this particular circuit. This circuit has a independent voltage source, 3 resistors, and a dependent current source. This dependent current source runs 1.5 times I1, where I1 is a current running in this branch. So first thing, we're going to find what is VTH. Now there are several different ways that you can think about this. It's basically trying to solve this particular circuit and find out what is the open voltage over here at A and B. Now how do we do this? We are going to think of this as a classical circuit. So the most obvious way is to use KCL and KVL. We're going to try KCL and KVL right now. And for this, we are going to assume that the voltage on this node, C here, is what we call V1. We're just going to give it a temporary name. And the voltage across A and B is VTH. So the first thing we can do is to find out the KVL around node, KCL around node C. KCL on node C. And we know that the current running in or out of this node has to add up to 0. The current running out of the 40 ohm resistor is V1 minus 20 volt divided by 40. And the voltage out of the 100 ohm resistor is V1 minus VTH divided by 100. And the current running in the branch of 200 ohm resistor, of course, is I1. We can either write it as I1 or write it as V1 divided by 200. That has to add up to 0. Now the second thing we're going to do is to write a KCL on this red node. So KCL on node A. It's actually the same as node A here. I'm going to use a different color here. So the current running into the red node consists of 1.5 I1, and the current running out of this node is the opposite of this particular current. Alright, so we're going to write 1.I1, that's the current running in, has to be equal to the current running out. And of course we know that I1 happens to be equal to V1 divided by 200. So now we have two equations. One of them is this, and the other one is this. And we can use this tool to solve for V1 and VTH. Okay, and I'm just going to write it down very quickly here. That's what the first equation simplifies to. That's what the second one simplifies to. Solving this, we find that VTH is 38.8